right, back to the structure of an atom in video 3. In this one, we're going to start specifically looking at the atom, and we're going to be looking at some vocabulary words and how we can use the periodic table. And in the next video, we're actually going to do some examples of calculations. So if we look at the properties of our subatomic, and remember, sub just means smaller, so smaller than the atom. So our beginning scientists didn't believe there was anything smaller than the atom, but we have proved them wrong. We have protons. Protons are represented with a P. They also have a plus, and that is because protons are positively charged. They have a charge of +1. You can find them in the nucleus, and they have the exact same mass as a neutron. Neutrons and protons have the exact same mass. Let's take a look at electrons. We represent electrons with an E. They also will have a negative with them, and that's because electrons are negatively charged. They have a charge of -1, and they can be found outside the nucleus. They are in that big, large, empty volume space. They are not inside the nucleus. And as far as their mass is very, very small. So it is a lot smaller than protons and neutrons. It's so small, it's out so many decimal places small that scientists really don't even account for the mass when you see the masses on the periodic tables. Electrons are so small that we don't even really worry about them. And then we have neutrons, and neutrons are going to be represented with an N. Sometimes you might see N to the 0, and that 0 is not positive or negative, so neutrons are neutral. They do not have a charge to them. They are found in the nucleus, so protons and neutrons together are found in the nucleus, and just like protons have the same mass as a neutron, well, neutrons have the same mass as a proton. Now, some other vocabulary would be atomic number and mass number. These are two words that you need to become very familiar with. Guaranteed that these are test questions. You need to know what the atomic number and what the mass number are. The atomic number equals the number of protons that are in the atom. So the number of protons, again, the positive charged pieces that are in the atom. This is unique. Every single element is different. So the number of protons that you have determines the kind of atom that you have. And I'll show a periodic table here in a moment. There are no two elements on the periodic table that have the same atomic number. Every single one of them is different. And with our periodic table, I want you to notice the top number in every box. So here's a 1, then 2 is over here, then 3 and 4, 5, 6, 7, 8, and they keep going in increasing numerical order. But that top number right there, that's the atomic number. It is unique. It is different. You won't find any two elements on here that have the same atomic number. In a neutral atom, neutral meaning that the atom doesn't have a charge to it, your protons have to equal your electrons. So if you have 7 protons, then you would have to have 7 electrons. Now remember, protons are positive, so that's meaning that 7 plus and -7, because electrons are negative, protons are positive, that equals 0. So if you have a +7 and a -7, you're going to get 0. And 0 is neutral. It doesn't have a charge. So this is an important piece of information. This will help you to calculate your electrons. So that's something to keep in mind when we get into the next video and we do some examples. The other piece of information that we said was important is the mass number, and this is the number of protons and the number of neutrons that are in the nucleus. The mass number is. And on the periodic table, you're going to see them as decimals, and that's because it's an average mass. But we're going to be rounding those to the nearest whole number. You can use this simple equation. If you want to find the number of neutrons, you're going to take the mass number, and you get this off of the periodic table. And you are going to subtract the atomic number. Again, you get this off of the periodic table. So you need to know how to read a periodic table so that you know where to get these numbers from. We already mentioned that this top number is the atomic number. Well, the bottom number in each one, and I know this is small, you will have a periodic table that's bigger. If I haven't already given it to you, you'll be getting that very soon. This would be the mass number. Again, from almost all of these, you're going to notice that the masses have several decimal places. Carbon, for instance, is 12.009. That's because it's an average mass. So for the mass, if you see 12.009, for instance, you would round that to just 12. So you always round to the nearest whole number. If it's 0.5 or higher, you round up. If it's 0.4 or lower, you would keep it the same. So 12.0, that 0 keeps it at 12 for the mass number. So you need to be able to use a periodic table and find those pieces of information. Another piece of information, and I actually referred to this in video 1, I said that we proved one of Dalton's pieces of theory incorrect later, and this would be where. Okay, if you think back or look back in your notes, we starred Dalton's second theory where he said all atoms of the same element are the same. I want you to take a look at the definition of an isotope. This says atoms of the same element can have different numbers of neutrons. That means that they are not all the same, and therefore Dalton's second idea that says that all atoms of the same element are the same is proved incorrect here. Because they have different neutrons, they are also going to have different mass numbers. So some of the things that will be the same, they're going to have the same number of protons. They're going to have the same atomic number. Things that are different would be the mass and the number of neutrons. So we'll talk about isotopes and something to keep in mind, something to remember. You'll see a few here on the next video. You're going to see this type of a symbol, and you're going to have some numbers on the top left and bottom left, and you need to know what those numbers represent. So a symbol is just a shortcut way of showing you some pieces of information, but it's not very helpful if you don't know what information it is, or if you mix these two up, you're going to miss some questions on the test. So this symbol is going to be whatever the element is. There are many symbols on the periodic table, so I just drew a generic X to represent the symbol. You would put the mass number here. This would be the rounded mass number. So for instance, for carbon, we would keep it at like that 12. And then the atomic number would be the one that we place at the bottom. Another way that we can write isotopes would be we can write them with the name fully written out, and then this number back here represents the mass number. And we don't see the atomic number when we write it this way, but we could look at uranium on the periodic table, and from the periodic table we can get the atomic number. So you don't always see this type of symbol, but when you do, you can still get the atomic number by looking at the periodic table. This number here is the mass number automatically. And that's where we're going to stop for today. In our next video, we're going to take a look at some actual example problems. And when you do those example problems, please make sure that you actually are filling out your notes. And I want you to try them yourself. I'm not going to do all of them for you anyway. You're going to have at least one to try on your own to be able to get credit for that. So keep that in mind. Some people like to use a calculator in the next video. It does have some subtraction, but other than that, it doesn't have any other math. So we'll end this video here.